Now let us see how the graph of a logarithm function looks like. It says that if base a is greater than 1, that is mathematically for any logarithm function of x with base a, this a, if it is greater than 1, means it is not just between 0 and 1, it should be greater than 1. The only condition is this. Then graph of log x with base a will look like this. Okay, this red function. Now here are some points that we can note from this graph. First is it is an increasing graph. Second means it is an increasing graph, as you can see. Second, it always lies on positive x-axis. Why positive? Because we know that for log x to be defined, x should be positive. Just remember the first condition when we defined the logarithm function. So this x has to be positive, then only you can find out the log of any number. Okay, hence the log will always lie on the right hand side of this y-axis. Okay, there is no portion which is towards left. Third is that as you can see here, that this graph is approaching to minus infinity as x is approaching to 0. So for x closer to 0, the graph is approaching to minus infinity. Right? So here we can have a relation that log of 0 is basically not equal to but tending to minus infinity. Now how we can arrive at this condition? How we can say that log of 0 is minus infinity? It is very easy. Why? Because something raised to power, let us say a raised to power minus infinity, if a is positive. Okay, you can write this as 1 upon a raised to power infinity. Okay, a raised to power minus infinity means 1 upon a raised to power infinity, and a is greater than 1. That means a raised to power infinity, this whole number will tend to infinity, and 1 upon infinity will tend to 0. So a raised to power minus infinity will tend to 0. That means a raised to power minus infinity will be almost equal to 0. So changing this to log form, so log of 0 with base a is always minus infinity or tending to minus infinity. Okay, that's why as x is approaching to 0, graph is approaching to minus infinity below y-axis. Okay, and obviously for x equal to or for x tending to plus infinity, log x will tend to plus infinity because it is an increasing graph. Okay, so third point is this, that log 0 with base a, this is tending to minus infinity. And fourth point is, as you can see here, that this point of intersection with the x-axis, this point is always 1. For any base a, means this a can take any value, log of 1 will always be 0. Okay, log 1 with base a is always equal to 0. Okay, log 1 with base a is always 0, and reason is same, that converting this into exponential form, a raised to power 0 will always be 1. Whatever is the value of a, something raised to power 0 will always be 1. Hence log 1 with any base will always be 0. Right, you can take value of base, any value you can take, graph of log will intersect at this point, which is always 1 comma 0. Okay, so these are the few points that you need to remember as far as graph of a logarithm function is concerned. Now let us solve some questions which involves properties of logarithm function that we have learned just now. So question number 1 is that if log 2 is r, log 3 is s, expressed in terms of r and s, first part log 16, b and c. Okay, so a part says that log 16 we have to express in terms of r or s or both r and s. So log 16 with any base, you can write this as log of 2 raised to power 4. I can write this 16 as 2 raised to power 4. Right? This means applying the property number 4, this exponent will come in the multiplication. I can transfer this here. So this can be written as 4 log 2, and 4 log 2 means it is just 4 log 2 value is r, it is given. So 4r. Okay, so log 16 is 4r. B part, log 18. Now here there are some factors for 3 and 2 also. It is not necessary that each and every question in each and every part we have to write r and s. Sometimes if you are finding the factor of 3, then only log 3 will come. Otherwise it is just r, or otherwise it is just s, not just r and s both. Okay, so log 18 means you just find out the factors of 18. This 18 can be written as 2 into 9. That means log, applying the first property, that log x into log y is log xy. Okay, so this is log 2 plus log 9. Now this log 9 can be written as log 2 plus log 9 means log 3 square. Okay, because I have to write not in terms of 9 but log in terms of log 3. So log 2 plus 2 log 3. Okay, log 2 is value r, and this is 2 log 3 means 2s. Okay, C part is log of 13.5. Okay, so this is, obviously we have to remove this decimal point, so I should introduce this as a fraction. 135 upon 10 means, this is log 135 upon 10 means it is 27 upon 2. Okay, because this is 27 into 5 and this is 5 into 2, 5 will get cancelled. So now property number third will apply, that log a upon b is log a minus log b. Log a minus log b, and this 27 you can write as 3 cube minus log 2 is just, let us write log 2. And finally I can write this as 3 log 3. This exponent will get multiplied here, 3 log 3 minus log 2. That means 3s minus r. Right, this is answer number 3. This is for B part and this is your A part.